Hi friends, welcome to the Unit 4, Day 3 notes. Today we're going to be in example 4, finding the domain of a logarithmic function. You've heard me talk about just noticing the domain. It's really just like a shift of how much you're changing your x values. It's really important to note that the domain is only affected by what's inside the parentheses. So if I had anything that's outside the parentheses, remember all that does is shift up or down, or maybe it reflects it, but it's not going to change my domain. For this one, for example, it's the 2x plus 3, that part right there, that's going to affect the domain. So what you want to note is that that part has to be greater than 0. So we're going to set what's inside this parentheses here. We're going to set that 2x plus 3. We're going to set that greater than 0, and that's going to give me my domain. So by solving this for x, subtract 3 on both sides, divide by 2, I get x is greater than negative 3 halves, which means that the domain for this is going to be negative 3 halves, comma, infinity. Now, I want to show you the graph of this so you can visually see what's happening. So, as you can tell, the graph only displays to a certain point, but in all of the graphing problems that we've done, we've noticed that it continues on going down. That is true of here, except what's happening is that the pixels are it can't get a smaller pixel width. So on here, the pixel width is only a certain size. So as we continue to kind of zoom in, we would be able to see more and more. It gets really close to negative 3 halves, but as soon as it gets to negative 3 halves, it's going to say that's undefined. And then to show you this in the table, here, at negative 1.5, negative 3 halves, that's where we first see an error. But if I picked negative 1.499999999, I still get a value of x. The problem is, even putting that in on this, if I go in and put in x equals negative 1.499999, at some point it gets to where it's saying it's rounding it. Oh, here it's rounding the negative 1.49. It says negative 1.5 is fine. It's not. Negative 1.5. See, it's not. But display-wise, it was not showing all, it was basically rounding all those 9s up. So I wanted to show that because that's a common misconception with these graphs. It's a limit of the technology. So just keep in mind that as we go forward. This one, I like this one. Domain. So again, we set 9x minus x squared, we set it greater than 0. Here what happens, you can factor out an x, and you get x, and then times 9 minus x is greater than 0. So here we're going to have a very interesting case because we have, so x is greater than 0, 9 minus x is greater than 0. So x is greater than 0, and then 9 minus x is greater than 0. So if I subtract 9 from both sides, I get negative x is greater than negative 9. Divide by negative 1. Change the signs! X is less than 9. So here we have, this is actually going to be a compound inequality. So we're going to be between 0 and 9, non-inclusive, like that. Now let me show you this one. Again, you can verify these yourselves by plugging them into your graphing calculator. But if you see this one, you see that it actually goes from 0 to 9, and it gives us a value. And you can kind of see it gets really close. Same idea here. Essentially, this makes like a nice arc with this one. So same idea here. So the domain, I guess I probably put the domain. This one's interesting because when we have the square root functions, we also have to limit the domain. So here we have 5 minus 3x is greater than 0. So if I subtract 5 on both sides, I get negative 3x is greater than negative 5. Divide by negative 3, and so you get x is less than 5/3. So my domain here for this one, x is less than 5/3. So that is that is it. So you don't have to like think of it, like you don't have to carry on more with the domain issue, because this is the part that's essentially inside the parentheses for the natural log. If you see a situation like this, where you have, without any set of parentheses, it's safe to assume in this case, because of that square root, that this is all being what's applied to the x, because it's all underneath that radical. Now, if you saw a situation where it had, so different problem, off to the side, here, so different problem entirely, if you had the natural log of square root of 3x and then plus 2, that plus 2 is not part of underneath that radical, so you would not include that plus 2 when you're finding the domain. And then my domain here is negative infinity to 5/3. Here's the graph of it, so you can kind of see. So that's 5/3, less than that. Now, this last one is so much fun because this is a rational function. Now remember, we have to think about abstractly, we're finding all of these domains. These domains have to be greater than 0. These values inside this x minus 2 over x plus 3 has to be greater than 0. Now, a lot of students will multiply x plus 3 on both sides. Okay, that's fantastic, but then we're getting rid of all of these values that we're dividing by. Instead, we need to think about what's really happening here between these. We need to find when these values are positive. I can't have negative values. So if I think about, let's just kind of think about this in, kind of a general way. On this graph, I'm going to have values that are greater. I could have values that are greater than 2. If I have values that are greater than 2, what happens? Well, this is going to be positive. This is going to be positive, so the whole thing will be positive. So let's think about this as cases. So this is, again, domain by cases. So I have one scenario where x is greater than 2. I have another scenario where x is between negative 3 and 2. And then I have another scenario where x is less than negative 3. So x is less than negative 3. X is between negative 3 and 2. And then x is greater than 2. So these are the different cases that we have. How did I get those values? I just looked at what was in the numerator and the denominator, and I took the opposite of that. So essentially, I solved each part for where its 0 was, and then used that to help determine what's happening. So if x is less than negative 3, so again, if x is less than negative 3, what happens? Well, then this is going to be a negative number. So if I say, again, negative 5. Negative 5 minus 2 is negative 7, so that's a negative, divided by x plus 3, so negative 5, that's also a negative. A negative divided by a negative is a positive. So this one is okay. This one comes out to be a positive. So this case is okay. If x is between these, let's use 0. 0 is a good value because 0 is between those. 0 minus 2 is a negative, divided by 0 plus 3 is a positive. Okay, that's not good. See, now I have a negative value. So I can't have that domain. That domain is not okay. X is greater than 2, so if I use 3, we already talked about this. This is a positive divided by a positive. That's a positive, and that's okay. So this is another way to think about just kind of domains. I used rational functions here for the example, but really you're trying to find where are you going to have positive values for it. So this one, my domain is x is less than negative 3 or x is greater than 2. So my domain is from negative infinity to negative 3, or, which is also the same as union. Union is not U. This is a union symbol. Very different. And then 2, comma, infinity. So that domain. Let me show you on the graph. This one looks really cool. I think they all look cool, though, because I'm a math nerd. So there we go. Same idea. So here in the middle, you don't see the graph because that's where it's negative. Can't have the domain. Thank you for joining me in this video on 4.3. Have a wonderful day.